solving systems of equations algebraically. Using the substitution method means we are going to take one equation that is already solved for one of the variables, either x or y, in this case it's solved for y, and we're going to replace the y in the other equation and solve for x. So this will give us 3x plus 5 times negative 3x minus 5 equals negative 1. Multiply out 5, we get 3x minus 15x minus 25 equals negative 1. Combine like terms gives us negative 12x minus 25 equals negative 1. Now we're going to add 25 to both sides of the equal sign, and that gives us negative 12x equals 24. Divide both sides by negative 12 to get x alone, and we get x equals negative 2. So if x equals negative 2, we still have to find y by replacing that negative 2 into the other equation and solve for y. The other equation was y equals negative 3x minus 5, and we found x to be negative 2, so replace that x with negative 2 and solve for y. This gives us y equals 6 minus 5, y equals 1. So the solution to the system of equations is the set of ordered pairs, or the coordinates, negative 2, 1. That is the point of intersection of those two lines. The elimination method, also called the addition method. When we solve a system of equations using the elimination method, we want to add the two equations together and eliminate one of the variables and solve for the other. So to do that, we need to make sure our x values are lined up and our y values are lined up and our constants are on the other side of the equal sign. Now when we add these together, we add vertically. 7x plus 5x is 12x. Y minus y cancels out, we eliminated y, and 22 minus 14. 22 plus 14 is 36. Now divide both sides of the equal sign by 12, and we get x equals 3. Now to find y, we replace x with 3 in either one of the other equations. Does not matter which one, just pick one. And I am going to use equation number 1, 7x plus y equals 22. And I'm going to replace the x with 3 and solve for y. This gives me 21 plus y equals 22. Subtract 21 from both sides of the equal sign, and we get y equals 1. So the solution to the system is the set of ordered pairs 3, 1. Sometimes, using the elimination method, if we go to add these together, we will notice that neither x or y will cancel out as is. That means we need to change one or the other or both of the equations so that the x values are exactly the same or the y values are exactly the same. It does not matter which one you change first. Just decide, do you want to eliminate x or do you want to eliminate y? In this problem, we're going to eliminate x. To do that, I need my x values to be the same. So I need to find a multiple of 5 and 3, which is 15. I want to change 5x to 15x, so I am going to multiply that entire equation, both sides of the equal sign, by 3. And that gives me 15x minus 21y equals 72. Now I want to change equation number 2 to have the opposite value, negative 15. So I am going to multiply equation number 2 by negative 5. Every single term, both sides of the equal sign. And that gives me negative 15x plus 25y equals negative 80. Now I can add them together and eliminate x. Negative 21y plus 25y is 4y. 72 plus negative 80 is negative 8. Solve for y by dividing both sides by 4, and I get y equals negative 2. Now to find x, I am going to take that negative 2 and replace y in either one of the two original equations. Does not matter which one you pick, just pick one. I am going to take equation number 2 that says 3x minus 5y equals 16. And I'm going to replace that y with the negative 2. So I get 3x minus 5 times negative 2 equals 16. Solve for x, multiply this out, gives me 3x plus 10 equals 16. Subtract 10 from both sides, and we get 3x equals 6. Divide both sides by 3, and we finally get x equals 2. So the solution to the system is the set of ordered pairs 2, negative 2.